From the main instructor panel, the instructor can adjust the size of the simulated patient's lungs by selecting adult male, adult female, or child. The inbuilt algorithm will define the total lung capacity of the simulated patient. For adults, this will be based on height, and for children, this will be derived from weight. The instructor can manipulate resistance to airflow for inspiration and exhalation. Furthermore, these resistances can be adjusted independently for the left and right lungs, allowing the instructor to create very bespoke ventilation training objectives. By default, the inspiration and exhalation resistances for each lung are matched. However, they can be adjusted independently to define pathology in an asymmetric fashion. Unlock by tapping the padlock icon. The app has multiple predefined compliance curves representing the most commonly encountered disease states. These have been categorized into mild, moderate, and severe, and the instructor can preview the pre-drawn compliance curves for inspiration and exhalation for each disease state. Additionally, the instructor can create their own bespoke compliance curve to match the learning needs of the teaching session. This can be done by tapping each of these 5 buttons across the bottom of the screen and adjusting the slider right and left. To adjust inspiration and exhalation compliances individually, there are buttons to press. When the instructor is happy with the shape of the compliance curve, they can save it for future use. The patient's spontaneous ventilation rate can be adjusted by tapping the tile in the bottom left of the main instructor panel. It is possible to change the patient's rate of breathing and the spontaneous tidal volume. By adjusting the spontaneous inspiratory time, the patient's IE ratio can be modified. The instructor can simulate active exhalation for a scenario of undersedation or severe metabolic acidosis. Inbuilt variability can be defined to mimic natural variations in spontaneous breathing effort and rate. It is possible to simulate the effect of common pharmacological muscle relaxants succinylmethonium and rocuronium. When activated, these will have a timed effect whereby the size of the patient's spontaneous breath will fall in a clinically appropriate time frame. At any time, the instructor can instantly paralyze the simulated patient. A range of emergency ventilation complications can be added to the teaching objectives to challenge the student to make appropriate interventions. From this window, it is also possible to add radiology investigations to the learning experience. Commonly or predictable investigations such as ultrasounds, x-rays, lab results, and EKGs can be shown on the iPad or tablet screen to enhance discussion and learning objectives. By increasing the resistance to exhalation and manipulating the student device, it is possible to simulate auto PEEP or breath stacking. This should prompt the student to change the ventilation strategy in order to prevent barotrauma and potential pneumothorax. All of these complications and student actions interventions will result in appropriate real-time changes to the waveforms on the student's simulated ventilator screen. A wide range of commonly used ventilation modes are available for the student to choose from. Pressure-controlled and volume-controlled modes can be selected, along with triggering functionality and synchronization for mandatory and supported breaths. These features will allow students to become familiar with the core concepts of mechanical ventilation, from initial setup to the process of weaning off the mechanical ventilator. A remote TruVent teaching session can be delivered effortlessly using the interactive remote learning integration. This integration provides TruVent users with a reliable solution for teaching mechanical ventilation virtually, irrespective of the training participants' locations across the globe. A remote session is quick and easy to set up, and the instructor can deliver the remote session on a one-on-one approach for assessments or multi-user approach for peer observation and learning. All actions taken by the instructor and student devices are displayed in real time. The highly interactive design allows the student device to take full control of the scenario, while the instructor device can interrupt at any time to demonstrate the correct course of action. Embedded screen sharing technology allows the instructor to view the student's actions live from within the instructor control panel. Embedded audio technology allows the instructor and students to speak directly into their iPad or Android tablet to discuss the scenario and provide feedback.